All right, everyone, get ready, because today we're going deep into the world of AI.
Ah, yes.
Specifically,
Sounds fun.
multimodal large language models. Those AI systems that can process both text and visual information,
Exactly.
like images and videos.
Right.
Taking a look at a new research paper, and the title is, well, get ready for this, PMOD, Building Mixture of Depths, MLLMs via Progressive Ratio Decay.
Quite a mouthful.
It is, I know.
Yeah.
But don't worry, we'll unpack it all. What's really cool about this paper is that it tackles a huge challenge with these MLLMs. You see, they're amazing, but they need so much computational power. This research wants to make them more efficient.
And that's important, really important. The more efficient these models are, the better, right? They'll be more useful. Think about it. You could ask an AI assistant to analyze a video, give you captions, or even search for images, but really complex descriptions.
That's the future, really.
So that's what MLMs are about. But the computational cost, well, it's been a big bottleneck.
Yeah, you could say that. So let's break it down. You said processing visual information
Yeah.
is a big part of the problem, right? Can you explain why?
Okay, so picture this. When an MLLM looks at an image, it breaks it down into tiny digital pieces. They call them vision tokens.
Vision tokens.
Yeah, and these tokens, they're like the building blocks of visual data. The issue is there are so many of them. It can be overwhelming, especially when you're dealing with high-res images or videos. It's like looking at a massive puzzle.
Oh, I see. Yeah.
Tiny piece by tiny piece.
Right. So it's not just about how smart the AI is. It's about the data, how much data it has to go through.
Exactly.
So how have researchers tried to fix this? How have they tried to make this whole process more efficient?
One thing they've tried is to compress the vision tokens, before they even get to the part of the model that processes them, like squeezing a file into a tiny zip folder.
That makes sense, but is there a downside to doing that?
Well, yeah. When you compress the visual information, the model has to work with less data. So you might lose some of the details. It's like trying to solve a puzzle with missing pieces.
So you might get the idea.
Right. But you'll miss some of the important stuff.
Got it. So that's where this PMOD technique comes in. It's not just squeezing the data. It's more strategic, right?
That's it. PMOD is all about helping the model prioritize, streamline how it processes things. Instead of, looking at every single vision token in detail, it focuses on the ones that matter most.
So it's like a detective, I guess.
Yeah.
He knows which clues to focus on and which ones to ignore.
A great analogy. So now let's look at the pieces of this PMOD technique. We'll see how it makes things so efficient.
Okay, let's get into it. Where do we start?
Well, the first part is something called mixture of depths, or MoD. It lets the model choose which vision tokens to focus on in each step of the process.
So the model is deciding what's important.
It is. It's pretty neat.
That's really smart. How does that actually work?
Okay, imagine you're reading a book, a long book.
Okay.
Instead of reading every single word, you get a summary of each chapter first.
So you know what to focus on.
Yeah, you see the important parts and can go back and read those carefully. The less important parts, you can just skim them. That's basically what MoD does. The model gets a summary of the visual information early on, so it can use its power on the most important areas.
So MoD helps the model prioritize. But how does it decide which tokens are the most important? How does it know?
That's where another part comes in. Symmetric token reweighting. They call it string.
String.
Yeah. String uses feedback from the language side of the model. The part that understands the text.
So the text helps make sense of the image.
It's like having a second set of eyes to help understand what's going on in the picture.
Oh, okay.
To make sure all this prioritizing and filtering works well, they added something called tan-gated weight normalization, or tan norm. It keeps the model stable during training.
Tan norm. Got it. So MoD is filtering, string is giving context, and tan norm keeps everything running smoothly. What else? What's the last piece of this P-on-D puzzle?
Here's the really cool part. The final element is progressive ratio decay, or PRD. PRD reduces the number of vision tokens processed in each layer of the model. Remember that summary the model gets? As the model goes deeper, that summary becomes more and more refined. The individual vision tokens become less important.
So the model is zooming out.
Yeah, like starting with a detailed map, and then you zoom out to see the whole city. You don't need to see every street anymore, just the overall layout. PRD uses this idea. It reduces the number of tokens the model needs to work with, making it much more efficient. They actually made a visual to show this called a shifted cosine schedule.
Okay, so we have MoD prioritizing, string adding context, tan norm keeping things stable, and then PRD streamlining the whole thing. Sounds impressive, But does it actually work? Does it make things more efficient without, making the performance worse?
That's the big question. To answer that, we have to look at the results, right? They tested PMOD against two other popular MLLMs, Alavio 1.5 and Alave NextT. They ran all these models through 14 different tests, benchmarks, to see how they performed.
Okay, so what happened? Did PMID pass the test?
Well, the results are really interesting, but maybe we should take a quick break before we get into that.
A cliffhanger.
Just a little one.
All right, we'll be back soon to find out what happened.
All right, so we were looking at how PMOD performed, right?
Right.
Against those other models.
Yeah, you left us hanging. What did the research show?
Okay, well, the results were pretty impressive. PMOD did really well. In a lot of cases, it actually did better than the other models, and it used, a lot less computing power.
Really? That's amazing. Can you break that down a bit? Like, how much more efficient are we talking?
Let's start with something called TFLOPs. It stands for, get ready for this, trillions of floating point operations per second. It's a way to measure how much processing power the model needs. So fewer TFLOPs. That means the model is more efficient. They found that PMOD used 44.4% fewer TFLOPs than the Lavi NextT model.
Wow, that's almost cutting the computing power in half. That's huge.
Yeah, it's a big improvement. And there's more. Another important thing is the KV cache storage.
What?
Cache storage. It's like the model's workspace, The bigger the workspace, the more it can handle at once. PMOD actually reduced that requirement by 46.2%.
So it's using its memory better.
Way better. And remember we were talking about how long it takes to train these models?
Oh, yeah, that was a big deal.
PMOD, well, it reduced the training time by 22.3%.
That's incredible. So we've got faster, more efficient, and the performance isn't worse. Anything else? Any other advantages to using PMOD?
One of the coolest things is that, well, it's flexible. You can actually adjust it.
Adjust it.
Yeah, you can fine-tune it. So you can find a good balance between efficiency and how well it performs.
Like a dial.
Yeah, you can control how much detail the model processes.
So PMOD is not just one thing. You can customize it depending on what you're doing.
That's part of what makes it so exciting. Remember those visualizations I mentioned?
Oh, yeah, the ones that show, like, how PMOD works.
They show how PMOD changes its focus as it processes information. You can actually see which tokens it chooses and how it gets rid of less important stuff as it goes along.
I'm trying to picture that, like a real-world example.
Okay, imagine a picture, right, with the person standing in front of a busy background.
Okay, I got it.
As PMOD looks at the picture, you can see how it focuses on the person, even when it's simplifying things, getting rid of some of the data. It's like the model is learning to ignore the distractions.
Ah, that makes sense. So it's not just about reducing data randomly. It's about choosing what matters most.
That's it. It's really, really smart. But, there's still some things to figure out.
Of course, it's still early.
It worked great with images, but we don't know how well it would work with videos or 3D stuff. That's something to research.
Right, it makes sense that there's more to learn. This is like the start of something big. What do you think, how could this research change things?
Oh, the possibilities are huge. If we can make these MLMs efficient without losing performance, well, it opens up so many new things. Think about AI assistants that can understand images and text, or educational tools that change for each person, how they learn best, or even in medicine, systems that can analyze scans and images super fast.
That's incredible. It sounds like it could really change a lot of things. But, with powerful technology, there are always risks, right? Ethical concerns.
It's a really good point. With anything this powerful, we have to be careful, make sure it's used for good. But we have to remember, it's still early days. A lot can change as things develop.
So it's about finding that balance, being excited about what it can do, but also, paying attention to the risks. What do you think our listeners would say about all this?
Yeah, what are their thoughts? What would they use this technology for? What excites them? What worries them? It's a good question.
Definitely. We'd love to hear from everyone. Share your ideas, your hopes, your concerns, anything. You can find us on social media. We're always up for a good discussion.
Absolutely. Now we're moving on to the last part of our deep dive. We'll look at some more details from the PMOD research and, we'll talk about what might be next for this whole field. Stay with us.
Welcome back, everyone. This is the last part of our deep dive into PMOD and, efficient multimodal large language models.
Yeah, it's been a great discussion. A lot to think about.
It really has. We've learned so much about how AI is changing, how it's understanding the world around us. Before we finish up, are there any other interesting things from the paper? Anything we haven't talked about yet?
There are a couple of things. One thing is that PMOD, it's not like a magic solution, It's more of a framework, something you can adapt.
So it's not just plug and play.
Right. It's not like you just plug it in and it works perfectly. It needs some tweaking, some
So
adjusting.
you have to customize it.
Yeah, exactly. They tried different ways of setting up PMOD and found that some things, like how many vision tokens are kept in each layer, well, those things can be changed to make it work better for different tasks.
You can tailor it to make it fit what you're doing.
That's the idea. That's actually one of the best things about PMOD. It's flexible. Researchers can change the balance between how efficient it is and how well it performs.
So it's like having a set of tools, and you choose the right one for the job.
That's a good way to put it. And it shows how important it is to understand not just how the model works, but also what you're trying to do with it.
Makes sense. You have to think about the big picture.
And this brings up another important point, training data. Remember we were talking about that symmetric token reweighting?
Oh yeah, the translator between words and pictures.
Right. The quality of that training data, it really matters. The more data you have and the better it is, well, the model can figure out the important visual stuff more easily.
So you need a good algorithm, but you also need to give it the right information to learn from.
Exactly. And that's actually one of the big challenges in AI, getting good training data. It's something researchers are working on all the time.
So it's like data is the food for AI.
You could say that if you want good AI, you got to give it good data. And that data needs to be, well, the right kind of data, relevant data. That's how we build systems that we can trust.
It's all connected. Okay, so we're at the end of our deep dive now. We've explored PMOD, this amazing technique that can make these multimodal large language models more efficient without sacrificing how well they perform.
We saw how PMOD prioritizes, streamlines, and how it can be adjusted for different things. It's pretty groundbreaking research.
It really is.
Yeah.
And it gives us a glimpse into what AI could be like in the future, right?
We might have AI assistants that can understand both images and text, personalized learning tools, medical systems that can analyze images super fast and accurately. There are so many possibilities.
It's exciting to think about how this technology could change things for the better. Of course, there are challenges, things to be cautious about, but I think it's important to be optimistic. This research shows what we can achieve.
Absolutely. We have to be mindful of the risks. But this research, it shows how creative and innovative people are. We're always pushing the limits of what's possible with AI, and that's a good thing.
So, to our listeners, stay curious. Keep learning about AI.
And think about the possibilities. If you could build the perfect MLLM, what would it be like? What would it be able to do? How would it change your life?
Let us know what you think. You can find us on social media.
We love hearing from you.
And that's it for this deep dive. Thanks for joining us, and until next time, keep exploring.